This is how to graph a linear inequality. Now this is the first of 3 videos. The first one, the equation is already in y equals mx plus b form, so it's already in slope-intercept form. In the other 2, the equation comes in different forms. So let's get started. So y is greater than 2/3 x minus 4. So first we need to figure out what the slope is and what the y-intercept is. Now you'll remember that y is equal to mx plus b, b being the y-intercept, m being the slope, and you'll remember that slope is in rise over run form. So our slope is 2/3, and that's a positive, and our y-intercept is -4. So we're going to go over to our grid, and we're going to plot our y-intercept. Now our y-intercept is going to occur when y is -4 and x is 0. So we're going to plot the point 0, -4. So we go over 0, down 4, and put a dot. Now our slope is 2/3, so that's rise over run. So our rise is 2, and our run is 3. That means we're going to go up 2 and to the right 3. Up 2, 1, 2, to the right 3. 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And I can work backwards. 1, 2, 1, 2, 3. 2, 1, 2, 3. 1, 2, 1, 2, 3. Now obviously I could also use a ruler once I have a sufficient number of points, but that will work just fine. So now I've graphed my line. The next thing I need to do is to figure out whether I need an open or a closed line. Now you'll remember that an open line is dashed. We'll call that open. And that means the solution cannot be on the line. So the symbols that will get an open line are greater than or less than. Closed line is what you normally think of as a graph. It's just a solid line. It's called closed. And the symbols that get a closed line can be equal to. So less than or equal to, greater than or equal to. And that means that the solution can be on the line. So I'm going to take a look at my line, or sorry, my symbol here. I have a greater than symbol, which means the values on my line cannot be part of the solution set. I must have an open line. Now the easiest way to do this is to just go ahead and graph a straight line and then go through with your eraser and just erase some points. And now you have a dashed line and you're good to go. The last piece of graphing a linear inequality is figuring out which region you're going to shade, because y can't equal this, but it just has to be bigger than this. So there are an infinite number of solutions. The only way to show this on the graph is by shading. So I'm going to plug in a point that is not on the graph. I'm going to plug in 0, 0. So my x value is 0, my y value is 0. So I'm going to say 0 is greater or equal to 2/3 times 0, which is just 0, obviously, minus 4. So 0 is greater than -4. That is a true statement. Therefore, 0, 0 is in the solution set. So the region with 0, 0 needs to be shaded. And so I will shade this whole region. And I'm done graphing this inequality. So I'm going to move on to this next inequality right here. I'm going to graph it quickly. Y-intercept is 5, 1, 2, 3, 4, 5, and it's down 1 over 2, down 1 over 2, down 1 over 2, and that's enough to sort of see where it's going. So I'm going to draw my line. Now I'm going to look for the open and closed. Y could equal this expression, so it's a closed line, it's just a solid line, so I don't need to worry about putting erasing to make a dash. And for the shading, I'm going to, again, find the easiest point to plug in, which is 0, 0. So 0 is less than or equal to -1/2 times 0 plus 5. So I get 0 is less than or equal to 5, which again